Alright, it should be up running. Good morning or afternoon, depending on what time you're here. You will notice I'm not in the room. Fortunately, we have enough technology here to make it seem like I'm still in the room. So for today, we're going to keep on working. We have our sub here who will be keeping an eye on you, helping you out if you need it, making sure you do not cause trouble. Remember, our first rule as 7th graders is you do not embarrass your teacher. Okay? Hopefully we were all reading what's up on the board here. You can see you're going to need your notebook, just like every day. No warm-ups today, though. We'll skip that. We'll start tomorrow. So our goals for today. We're going to take our formula chart, which we titled, but we didn't actually do anything with, and we're going to fill in everything that we did from last week. Once we finish with that, we're going to talk about circles, which will be our last two-dimensional shape that we discuss in here. And then we'll just do some extra stuff with circles. Okay? So let's go ahead and get started. So we're going to go on page 29. Let me check, make sure I'm actually picking this up. Alright. So on page 29, we should have titled it Formula Chart in our notebooks. I don't know. Let's see. There we go. I can take all the bad stuff I write with my tablet at home and make it nice and pretty for you. So let's see, on page 29, the formulas we started with, the first shape we did, we talked about rectangles. So on our first line, we're going to say rectangles. And then we just look what formulas did we have for rectangles. This is the Dora the Explorer part of this, where I ask questions, but I can't hear you answering, so I'm going to assume you give me the right answers. And so I'm going to assume we all said that rectangles, we have a formula for perimeter, which was, we said that was 2L plus 2W, or 2 times length, or L plus W, where L and W are just length and width. Alright, in addition to perimeter, we also had area. Oh, that's awful. Area. That's better. We said that the formula for area of a rectangle, yep, nice and easy, just length times the width. Alright, that was rectangles. Then move on, we went to triangles. Oh, wait, no, that's not right. Before we did triangles, we did parallelograms. Thank you for correcting me. I'm going to assume someone corrected me. Parallelograms. And what formulas did we have for that? Very good. We said that area was base times the height. Notice that a lot of similarities between length and width and base and height, because remember we said that every rectangle is just a parallelogram. So if you need to just want to think of rectangles as base times height, that's fine, because it's just one side times the other. I'm sure someone in here is complaining that we didn't write down squares anywhere. Squares are just rectangles, so if it works for a rectangle, or if you have a square, use whatever formula you have for a rectangle, because they're the same. Alright? Let's see. That's nice. Let's go with a different color. Then we had triangles. Okay, triangles. What was the formula that we said we had for triangles? That's right. The formula for triangles was always green. Area and that's base times height. Actually, I don't want to change formats halfway through here. So I'll put the dot in between. Base times height. Now the difference between that and rectangles, we said we had to cut that into two pieces, so it has to be base times height divided by 2. Okay, base times height divided by 2. Or, if you're not happy with the division thing here, we can also say that's 1/2 times the base times the height. Same thing, either way. It is important that you remember that if you have a triangle, it's always base times height divided by 2. Don't forget about that. Don't just try to use this formula for everything, because you will get stuff wrong. Okay? Extend this out a bit. And the last shape we worked with, that's right, we had purple trapezoids. And what was our formula for trapezoids? That's right, again, we have area. And this one was a little different because remember trapezoid had 2 bases, so we said it was base 1 plus base 2. All that times the height, and then we divide that by 2. Okay? And if you're not sure about where any of these came from, you can check your notes. If you aren't here for one of these days, you can check eChunk, which has the notes. Other than that, I mean, all this stuff will be on a formula chart. So you don't need to memorize it, but it would never hurt to do that. Okay, so that's what we have so far. So let's go on to something new now that we have all this down. Actually, I guess I can give you a few more seconds to write this down. Doing pretty good on time. Hopefully no one's causing any trouble. Okay, let's go on. So let's turn forward now. Let's go to page 37. We should have something written on every page up through 35. 36 should be blank right now. We're going to skip to page 37. Here is our title. We're going to draw a circle over here. And we're going to have 4 different parts that we're going to define in a little bit. So I'll give you about a minute to copy this down. Here's my handy timer. All right. This is a little bit boring without kids here. I'm just sitting here in my living room watching the Patriots game. 40 seconds. 35, 34. All right, this is boring. I'll move on. 20, 15, 10, 5, 4, 3, 2, 1. Beep, 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 beep. Alright. So, before we even start on this, let's look at something cool about circles. At least I think it's cool, and you'll think it's cool. So what we have here is this little program that will find you the area of any shape. And we can see, we don't really talk about it, but every shape you've ever drawn always has a radius, just like a circle does. And it's just the distance from one corner to the very center of a shape. So let's put on side length here. So we can do this for any side, or any shape with any number of sides. It won't let me do less than 3 though. Anybody have any idea why it wouldn't let me pick a shape with less than 3 sides? Good, because obviously you couldn't have a shape with less than 3 sides. If it was just 2 sides, it would be nothing. You have to have at least 3 sides. So what we want to look at is we're going to add more sides to this, but we're not going to change this radius. The radius is always going to stay as 6. So we can see this will stay the same. We're going to see how the sides change, and the length of the side is going to change. So if I add a couple more, we can see that as we add more sides, the side length actually goes down. So right now we're at 10 sides. Well, hopefully we notice something. If I'm going to go back real quick, is what is happening to our shape as we add more sides? Well, hopefully we see that it's becoming almost more like a circle. It's sort of rounding off. The more sides we add, the more it sort of gets round. So hopefully you're saying, what if we did 10 more? Well, let's do 10 more. You see the radius still not changing. Side length getting smaller all the time. Even now we're at 20 sides, and it's even more evident that we're sort of really rounding off. We still have edges here, but they're getting shorter and shorter. So if I keep going, keep on going, there's 30, 40, 50. Well, now we saw these sides, and it's looking like 0.8. It's getting cut off here. And if we keep going even more, I can just keep on going and going and going. I can't even see the length of my side anymore. I know it's just point something. 99, 100. So now we have a 100-sided shape. And it's real hard to even see where the individual sides are now. But what shape does it look like? Kind of looks like a circle. So this leads you to another argument you can have with your math teachers at any point, is that some math teachers will say, well, a circle doesn't have any sides. Which is true, because when we think of a circle, it's just one curved edge. Well, can't call it a curved edge, one curve. But looking at this, we can see if this kept on going forever, we can see, what if we had 1,000,000 sides? Well, what's the difference between a circle with 1,000,000 sides and a shape with no sides? They both be about the same. So just something to think about. Also your basic calculus for the day. Alright, let's go back. So here's our shape. Here's circles, everyone's favorite. So let's start. Let's define the parts of our circles. First thing we always talk about is the radius. So what is the radius of a circle? Okay, hopefully somebody said it. Good. That the radius is the distance from the outside of the circle to the center. So anywhere we can go from the center point here to the outside. I'm going to try real hard to draw a straight line. Oops. Anywhere from the center of the circle to the outside is the radius. So there's an infinite number of radiuses anywhere in the circle. You can draw them anywhere. So let's copy this down. Distance from the outside to the center. Okay, after the radius, we always talk about diameter. So what is the diameter? Good. Diameter is this length here. It's anything that goes from one side of the circle to the other. The only thing you have to remember is that it has to go through the center point. If it doesn't go through the center, it can't be a diameter. Let's see if I can. Yeah, that's pretty. Okay. So diameter one side to the other. It's kind of really a big deal that we can tell the difference between diameter and radius, especially in 7th grade. I don't want to send you into 8th grade with you not being able to tell the difference between what's a radius and what's a diameter. So try to keep that in your memory. Alright, next thing is the circumference of a circle. And circumference is what? Okay, good. Circumference is this distance around the outside. So all the way around the outside is the circumference. And hopefully someone wonders, well, why is it called circumference and not the perimeter? Because we always said, we said last week, that the perimeter was just a distance around the outside, and now we're saying circumference is a distance around the outside. Well, that gets a little bit technical, but really we can just say that circles are special. So they get their own word. If you actually look it up in math dictionaries, it'll say perimeter is distance around the outside of a polygon, which is something like a square or a triangle or a pentagon, something that has edges. And we said earlier that a circle doesn't really have edges, it just has curve. Which is why it gets its own word, in case you're wondering. Alright, and the last thing, area, is just the stuff inside. Nice and simple. Hasn't changed. Area is always the stuff on the inside. I say stuff. If you want the more technical word, you could always say the region inside a circle, which is a more accurate definition, but I think at the 7th grade level, stuff works just fine. So here are 4 parts. Radius, blue, diameter in red, and our green circumference. Alright, so that's that. That's all you need to know. All these 4 parts. So let's do some formulas with them. So radius and diameter. We're still going to go on page 37, so this can just go right underneath everything we've already done. And let's see. We're going to make another circle. Don't make the circle too big. It just has to be big enough that we can look at. Okay. Actually, maybe a little bigger. Oh. So now if I make a point in the center and draw it out, and I call this length 4. So is this length a radius or the diameter? Okay, good. This is the radius because it goes from the center of the circle to the outside. So I can say that the radius equals 4. Simple. Now if I kept this line going, if I went to the other side, if this length over here is 4, what does this length here have to be? Okay, good. That would have to be 4 as well. So now we have 4 and 4, which makes a total of 8. And so what does this length 8 represent? Okay, good. That's 8 is the diameter. It's distance from one side to the other, and it should pass through the center. It's not quite clear by my drawing, but you get the idea. So you can say diameter equals 8. So that's good, because now we can see radius and diameter, how they're related. Now I want to do it using just the symbols, because this only works for this one circle. We say 4 and 8. I want to do this for any circle. So what we have to look at is how are radius and diameter related. So let's start with diameter. So I want to say D is equal to what? Not just for the circle, for any circle. So what we can say, hopefully somebody said it, if not, here we go, is that we have this radius plus this radius. So we say that's 2 radiuses. So I can say diameter is always equal to 2 times the radius, right? Because we said up here, well, the radius is 4, diameter is 8. Well, 2 times 4 equals 8. So we can say this formula works. D equals 2 times the radius. So, and now we can do this going the other way as well. If I want to figure out the radius, how could I figure that out in terms of the diameter? Take a couple seconds, about 15 seconds, and think about how could we write that out. R equals what of D? Okay, so time's up. So if we look at it, we can say, well, radius is smaller than D, so I can't add to it. It's got to get smaller. So what operations do I have to make things smaller? Well, I have subtraction. I don't really want to use that. How about division? Well, what can I divide 8 by that'll give me 4? Well, that's just 2. So I can say that if I take my diameter and I divide it by 2, maybe that works. So let's try with our example here. This one we said diameter was 8. So now if we take 8 divided by 2, well, we get 4, which is what we said the radius was. So this formula works too. We can say the radius is always equal to the diameter divided by 2. So hopefully this is something we already knew, that radius is half the diameter, and the diameter is twice as much as the radius. This is kind of a big deal. So let's... Ooh, that came out awful. Let me try again. We're going to box this off. Okay, that's still bad, but whatever. Box out. There's our two formulas. Formula for radius, formula for diameter. Okay, so far, so good. So let's do one more thing on page 37. We got all this. We got radius, diameter. Let's talk about the circumference. And again, my handwriting is awful. So let's fix that up. So circumference. So let's look at this a little different. I'll give you the formula for this one. We can say that the circumference, or C, equals, and I'm going to give you about 20 seconds right now to make the point that yes, C equals looks an awful lot like a smiley face. Okay? Make your jokes quickly. Get it out of your system. Ha ha ha, yes, it's very clever. C equals is a smiley face. Happy face equals whatever. Okay? We've had our time, now we're done. C equals. It's not a smiley face, it's C equals. That's it. Alright? No more jokes. Alright, so circumference equals, there's two different formulas for this. First one is pi times d. Okay? Pi d. Alright? And to try to make sense of this, because you're like, well, where did this pi come from? Well, first of all, we always talk about pi with circles, but let's see if I can't make a little bit more sense of it. So what we have here is we got a picture, and we'll wait for it to go through. Alright, we're going to watch this a couple times here, because it goes kind of quick. We take a circle, and we unroll it. Alright, that's what circumference means, going around the outside. So we have 1, 2, 3, 4. We're taking the diameter 4 times, laying them out next to each other. I wish this went a little bit slower for me. So you see 4 diameters. We go all the way around the outside of the circle. It doesn't take 4 diameters to get all the way around. It takes a little bit more than 3. And it just so happens that it is 3.14159, whatever. There's always this relationship in circles that the diameter and circumference is always about 3.14 times bigger than this diameter. One more time. Okay? And what this leads to is this, our formula here, the C equals pi times diameter. It's always the diameter times a little bit more than 3. Okay? So I said there's 2 formulas for circumference, so we can come up with the second one pretty easy. We say, well, let's replace diameter with something else. Well, what did we just say diameter was equal to on the last page? If we look back, we said what? D equals 2 times radius, right? So all I got to do is I take this formula, and I replace D with 2 times the radius. Pi doesn't change. Pi is happy being pi. So C, our circumference, also equals pi times 2 times the radius. Right? So this is correct, but usually the way we do it in math is they try to put the regular numbers first, and then pi, which will never change, so it's constant, come after 2 times pi, and then radius, we don't know, goes at the end. Slide this over. And make a better C here. All right. So our two formulas, we have, let's go purple. Circumference is pi times diameter, or circumference is 2 times pi times the radius. Both of these mean the exact same thing. It just depends on what the problem asks you. So if the problem said, well, your diameter is 5, find circumference, well, we'd use this formula because we'd have diameter. But if it gives you the radius, well, it wouldn't make sense to turn the radius into a diameter just to use this formula. So if they give you radius, you can use this formula here. Okay? And we'll practice that in a little bit. Before we do that, though, actually, let's draw ourselves a circle here. Oops. So here's a circle. And let's say that it has a diameter of, or you know what, we don't know the diameter. Let's say the circumference of this is 42. So 42 is our circumference, and we want to find the diameter. So how could we go about doing that? So what do you think? So here's what we know. We know circumference. We're looking for diameter. So if we're looking for diameter, which of these two formulas would it make more sense to use, green or black? Okay, hopefully we're all saying black, because if we're talking about diameter, let's use a formula with diameter in it. So I'm going to start with that formula. So I'm going to copy this down, C equals ID, okay? And I'm going to fill in the information I know. Well, I know the circumference is 42, so I can say that instead of C, I can write in the number 42 equals, and pi, let's put pi up here. Pi doesn't have an exact number attached to it. So we can never say equal, so we put the little curvy equal sign here, which means about, or approximately. And we can say 3.14, which would be the best number to use. And so if you're taking a test and they say use 3.14, use 3.14. But in the interest of this not taking all day to figure out, we're just going to use 3 for pi. Now don't get confused. Don't let this make you think that pi equals 3, because it doesn't. Don't ever go anywhere and try to say pi equals 3, or they'll make fun of you. Okay? But for the sake of doing easy math in class, we're going to say we're going to use 3 for pi. So I'm going to replace this pi with just the number 3. So now we've got 3 times the diameter. Alright? So now, let me ask you, if we know this, now how can I find the diameter? Hopefully someone right now is telling me, well, we could divide. We could say 42 divided by 3. Let's try that. Thank you for the suggestion. So 42 divided by 3. So this gives us 1, 3, 1. Bring down to 2. 3 goes into 12 4 times. So maybe the diameter equals 14. Well, let's try it. Does 3 times 14 equal 42? Yes, it does. This is exactly right. Our diameter right here is 14. Which is good that we figured out for this one circle, but I want to be able to figure it out for any circle. So let's think, what did we do? Well, we took this circumference and we divided it by 3. And so I can go back and I can write this in symbols. Instead of 42, I can say C. And now I divided it by 3. But I don't want to use the number 3 because 3 really represented our number pi. So I'm going to say that C divided by pi And the answer that gave us was 14, and 14 represented the diameter. So now we have this bonus formula, and this can be used to figure out the diameter. We can always figure out the diameter by taking the circumference, the distance all the way around the outside of the circle, and dividing it by pi. So here's one more formula to remember. Okay? So that's good. But now hopefully someone's saying, Ellis, well, can I do that for this formula here? Well, of course we can. Good question. So we can use our same circle here, except now I want to figure out what is the radius. And hopefully you already know, well, radius has to be half the diameter, so it's got to be 7. Right? But let's assume we didn't do all this first, and we're just going to go off of this formula. So again, we can copy it down. We can say C is 2 pi r, right? And we're going to fill in the information we know. So we still know circumference is still 42. 2 is just 2. That's just a number. Pi, we said we can use 3 for pi, so that's going to be times 3. And the radius we're not sure of yet. So now we can do some of the math here. I can say 2 times 3 is 6. So now 42 equals 6 times radius. Well, now we're looking at a problem awfully a lot like this step right here, where we think 6 times what number gives us 42, or we can work backwards and say, well, what's 42 divided by 6? So, wow, this doesn't really show up, but it's okay because we already know the answer. 42 divided by 6 is 7. So we can say radius is 7. Okay, so 42 equals 6 times 7. So now all we got to do is figure out how to get this back into a form that looks like this, with all the symbols instead of numbers, so we can use it all the time. So let's do that. So 42 is the circumference, and now we divided it by 6. So now, where did the 6 come from? Well, 6 was 2 times 3, and 2 times 3 was 2 times pi. So I'm not going to write divided by 6. I'm not going to write divided by 2 times 3. I'm going to go right back to our original formula. So I'm going to write 2 divided by pi. So we take the circumference, we divided it by 2 times pi, we divide it by 6, and we always will end up with this radius. Isn't that handy? Right? Maybe not. So that's it. We've got now 4 formulas, all having to do with the circumference. We've got pi d, 2 pi r, and then c divided by pi equals d, c divided by 2 pi equals r. This is all real important for what we're doing this week. You are going to be able to need to understand where this comes from. But we'll talk about it more tomorrow when I'm back. So that's it. Let's see, what do we have next? We have area. I want to hold off on area until, actually, how are we doing on time? Let's hold off on area. So 35 minutes in, almost that time. So tomorrow, assuming we didn't cause any trouble for ourselves today, we're going to take some paper plates. You don't have to write this down. Don't write this down. We're going to use paper plates, colored pencils, and scissors. Did I spell that right? I don't know. Scissors. You know what scissors are. We're going to use these 3 things to prove how to find area of a circle. And just to tease you, the formula for area of a circle is A equals pi r squared. And we're going to figure this out. We're going to go back in time. We're going to do what the Greeks did, and we're going to figure out how this area worked out. This is, of course, assuming we're good. If we're bad today and we're taking names, we could always just do this through worksheets, and that will be a lot of fun for me, not for you. So hopefully we're good. Also, I don't have a whole lot of colored pencils, so if you have colored pencils, you might want to bring some in tomorrow. Just saying. Okay? Alright, so let's practice a little bit. And we got a couple circles here. We're going to go over to your side. So let's copy these two circles down. Leave yourself about, I don't know, like 3-4 spaces between these two. And I found this out last year. It's pretty clever. We can find 4 things about a circle. C-A-R-D, which spells the word card. Where C is circumference, A is area, R is the radius, and D is the diameter. So let's take, where'd my timer go? Let's take about 2 minutes. And if we can find out what the circumference, the radius, and the diameter of these two circles is, that'll be good. If you want to do a little bit of bonus, you can also find the area. Remember we said that area is A equals pi r squared. If not, that's okay. But I do want you to be able to figure out what is the circumference, what is the radius, what is the diameter of both of these shapes. So let's do this on our own, 90 seconds. I just want you to try it. We will go over these in 90 seconds, so just put your best effort towards it. 1 minute. It's almost nice doing it this way. I can go to the fridge while y'all are working, find a snack, come back. I'm assuming you all are still working. It's a little boring though. I don't know how Dora's done it all these years. Talking at a whole bunch of people that you can't hear. Alright, cool. So let's see what we got here. Let's start nice and easy. What is our, well, what do we know? What does it give us here? Does it give us the radius or the diameter? Okay, good. Gives us the radius. Radius is 4. Right? So the easiest thing we should be able to figure out from that is what is the diameter? Because we know diameter is always just twice as much as the radius. So if this length over here is 4, that means this length over here has to be 4. So 4 plus 4 makes a total of 8. Okay? So radius 4, diameter is 8. From this point, if I want to find circumference, we can use either formula. I always like to go with the diameter formula if I can because it's less stuff to work with. I know C is just pi times D. And I know that I can use 3 for pi because I'm nice. So 3 times D. And if you ever need to remember this, the 6th graders last year, we came up with, I thought it was clever, is when you go to the movies, how do you want to see it? You want to see it in 3D. So what's the formula for circumference? C, it's 3D. Hopefully someone laughed at that. If not, I don't know why you don't think my jokes are funny. Alright, so C equals 3 times diameter we said is 8. What's 3 times 8? Well, that's just 24. Okay, if you wanted to find the area, we said A was pi r squared. So pi we can say is 3. The radius is 4 squared. Order of operations says we have to do the square first, so 4 squared is 16. And times 3, so area equals 48. Because 3 times 16 is 48. Okay. 41 minutes. Alright, one more. So, the next one, down here, what does it tell us? Okay, good. We know that this distance here is all the way across the circle. Goes from one side to the other, passes through the middle. That means it has to be the diameter, so diameter is 12. Okay, if that's the diameter, we can find the radius by splitting it into 2 pieces. So half of 16, or half of 16, I don't know where I got that from. Half of 12 would be 6. 6 and 6 makes 12. So the radius here has to be 6. Okay, for circumference, again, I can use this formula. C equals pi d. Pi is 3 because we want to see movies in 3D. Aha! I'm going to keep saying it until you think it's funny. So pi is 3. Diameter is 12. 3 times 12 equals 36. Right? And then area of this one would be 3 times the radius, which is 6 squared. 6 squared is 36 times 3. And then 3 times 36 we could work out is 108. Okay, again, if we didn't get area, that's okay. We're going to spend all day on area tomorrow. So that's it. That's circles. That's circumference, radius, diameter, and a little bit of area. So what we're going to do, we're going to practice on our own. We're going to pass around a page for you to work on. You've got about what should be about 8 to 10 minutes. Whatever you don't finish, you're going to take home tonight and bring it back tomorrow. Okay, so for the last 10 minutes class, hopefully we're passing this paper out right now. We're going to finish. This paper being passed out. We need to finish it in class before it becomes homework. I don't think you have a choice between the two. You're going to try to finish it in class. You don't just put it away. Everybody needs to be working on it. And if you don't finish it, it becomes homework. That's awful. I need to work on my handwriting. That's pretty cool. So everyone should be working on this. Remember we said if you're working today, tomorrow we can do this with paper plates, arts and crafts style. If we're just going to play around the last 10 minutes, we're going to do it with worksheets tomorrow. Okay? So you can do worksheets today, you can do worksheets tomorrow. Choice is yours. Okay? Encourage your partners and classmates to get to work. Okay? Good luck. I will be here after school, so if you're not sure on how or what we did today, you can always come by and see me. I apologize for not being in there with you today. Okay? So good luck with this. and we'll see you tomorrow.